So now we want to see how we can reduce linear ordinary differential equation to a system of ODEs, or first order differential equations. Suppose you are given a differential equation of nth order. As you can see, this is a differential equation of nth order Dn. You can reduce this system to a first order matrix system in the form of x prime is equals to AT. AT is a matrix of coefficients, and then we have got a xt, a matrix of variables, and then ft, a matrix of the homogeneous part. This one, right? So step number one, if you want to reduce a system to an linear ordinary differential equations to a system. So step number one, we rewrite the nth order ODE in the form where we rewrite it in terms of the highest order derivative. So you make the highest order derivative the subject of the formula. Then step number two, you define n new variables. You define n. So if the highest order is 5, so you need to define 5 new variables. If the highest order is 20, you need 20. If the highest order derivative is 5, you need 5, and so on. Define 5 new variables, and then these new variables will be iterated by the equation. These new variables will be iterated by the equation. Say now you've got your 5 variables, so you differentiate them. In this case, you've got your n variables, so you differentiate them to iterate them. So this will be your n1 will be given by x1, be given by x2, x2 prime will be given by x3, and so on. Then you can then write your equation. Right, so let's look at this example. Right, so you want to put the initial value problem of x prime prime plus 2x prime minus 8x is equals to e to t. We are also given the initial conditions for this one. Then you're asked to find the system. So first step, you are writing this problem as the subject of the highest derivative. So you make the highest derivative the subject of the formula. So this would be x prime squared is equals to this, and then since this is the derivative, the derivative there, n is 2 because it's second derivative. So you need 2 variables. So our 2 variables will be x1 and x2. x1 will be equal to x, and then x2 will be equal to the derivative, because we want to remove the first derivative, so that we make this the first derivative. So I want to substitute by these variables. Right, so how do we create the variables again? You've got a differential equation of second or highest second order derivative. You need to come up with the 2 variables. If you had a derivative of 3 there, you will have x3 is equals to x prime prime there. Remember that iteration there that we had on our previous slide. Therefore, the differential equation is second order, so we need 2 new variables. So now that we know this, so we need 2 new variables, and then remember we are supposed to write this in terms of system of first order derivative, so this should be your new variables. So the new variables here in terms of derivatives should be x1 and x2 prime. So differentiating this one, if you differentiate this, your x1, you will get, if you differentiate your x1, you will get x prime. But you know that your x prime is equals to x2, so this is equals to x2. Coming to the second one, if you differentiate x2, you get x2 prime. This one, so you get x2 prime. If you differentiate this, you get x prime t, but you know that x prime t is equals to x prime t is equals to this, which is minus 2x prime plus 8x plus et. So you substitute there. Now we have got your two derivatives. The first one is given by x2, and then the other one is given by this. You need to substitute for x2, x prime and x prime. You know that x prime is equals to x2, so you substitute for x prime there, substitute by x2, and you know that this x is equals to x1, this x is equals to x1, so we substitute for this. So it follows that this one, we agree that it's x2 and this is x1, so it follows that this first equation will be given by x2 t, and this one will be given by x2 plus 8x1 plus t, e to the t. Right, rearranging this to, you can see that the x2 correspond to this, because now we want to write this in terms of matrices. There is no component there in terms of x1, so this part will be 0, and there also no component there in terms of e to the t. The only component that are in both equations are these ones corresponding to x2. So writing this in matrix form, so the derivatives will be x1 prime x2 prime bracket, which is equals to this one. For x1 we've got 0 and 8 coefficients, so this would be 0 and 8. This one, the coefficient is 1 and minus 2, 1 and minus 2, and these are your variables. You have got two variables, x1 and x2, x1 and x2. And then for the exponent, or for the non-homogeneous part, here you've got 0, 0, and then here you've got e to the t, then you've got e to the t there. Then you've managed to write this in terms of x prime is equals to at xt plus ft. Right, remember you are given the initial conditions. You are given that x1 is equals to 1 and x2 is equals to minus 4 at t is equals to 0. So substitute this, so t is equals to 0, substitute there, t is equals to 0, and then x1 and x2, we are given that this matrix is equals to 1 and minus 4, 1 minus 4. So if you multiply this, this will be 0 times 1, give you this, 1 times minus 4, it gives you this, 8 times 1 gives you this, minus 2 times minus 4 gives you this. So this will overall give you 0 minus 4 plus 0, which is minus 4. This will give you 8 plus 8, which is 16, plus 1, which is 17. So that will be your solution. That will be your solution. Thank you.